Assalamualaikum warahmatullahi wabarakatuh. My name is Nabil bin Hamidy. I would like to present about Lab 3 AC voltage measurement and monitoring. My other group member is Khairool Aizat bin Razak, Mohammad Izzul bin Ramlan and Mohammad Iqram bin Abdullah. So this is a construction of parallel AC high voltage measurement using FC and picoscope. So from FC panel, the ground switch is connected to the dish, and then the left and neutral cable is connected to high voltage transformer, and then from high voltage transformer, the connect to 100 picofarad capacitor using connected card, and this the grounding is connected using coaxial cable uh, from FC panel, high voltage transformer, and then capacity 100 picofarad capacitor, and also this one and this one. The from this one, it connect using BNC payment to banana connected. And this one is BNC T junction. To connect to frequency converter to VM1, and then to picoscope. So next, the safety rule. The safety rule: first, using glove for protection. Second, using a fencing for protection. Third, the closure of which is the end of the safety circuit. Connector must be used for the cable. For interlocking link, shield cable must be used. In any device state, the normal switch functionality can be used. The ground switch does not substitute a ground rod with functional security, but always verify that live parts are properly grounded. The FC case is grounded with the input power and the low inductive earth connection. So, thank you. We move to section 2, which conducted by Khairool Aizat. Thank you.
Okay, next I will proceed with the system monitoring of secondary side of the transformer with 8 slots. VM1 is for AC and for RMS and RMS1 measurement. VM2 is for slot 3 and 4, which are peak value, and RMS2 measurement. VM3 is for measuring 3, VM4 is for measuring 4, VM5 is for measuring 5, VM6 is for measuring 6. The alarm system. When the alarm indicates a red color, it is meaning that you are not allowed to do any injection. The situation shows that there must have some condition that we are not fulfilled yet, like closing the control room's door properly or the emergency button is not released. All these conditions can be seen at the lock window in the kit control. To enable us to do injection, we must clear the alarm by pressing reset, and it will turn into green, meaning that it is under good condition.
Okay, Assalamualaikum. My name is Razak bin Razak. Today I would like to present the section 2 of lab 3 high voltage, which is procedure before run the measurement. Firstly, connected the PC to the frequency converter by Ethernet cable and use the picoscope to see the wave shape. If just use the kit control, it just to monitor the value as RMS, RMS1, peak and RMS2. For the picoscope, have 4 channel can be inserted, and by using the kit control monitoring, have 8 slot to show the measuring channel. Okay, for the second point is after that, when we go to the test field, and ensure to use the protective tools like special protective glove because it can stand up to 30 kilovolt, so can prevent from any accidents. Before do the experiment, must discharge any power and ensure to check the cable should not cross each other. Okay, for the point 3 is after that, connect all the variable and exit the test room. Before that, important to close door properly to make sure the latch is active to make any injection. We must consider looking at the properties on the secondary device that have serial number and check in manual book to choose the right setup. Okay, next for the fourth point is after that we can use KIT control, and there are 6 terminal VM1, VM2 for the SC. Okay, for the VM1 has 2 slots such as RMS and RMS1. Then we check the alarm when it show the red color, so the injection cannot be done. So we need to press the reset toggle to change the alarm turns green color. It is because of might something problem occurs at the door, like the door does not close properly when the emergency button activated. To solve this problem, first must close the emergency button and then close the door properly, and lastly press the reset button and see if the green color at the alarm to show is mean is ready to start the operation. For the FC setup, just use the default setup at the software setting, then press the customer setup and the manual step with setting to manage the gain such as 0.1, 1 and 10. For the impulse sequence setting, we'll also use the default setting. For the calibration part, it is very important to make the right setting. The slot 1 must be setting as 19651.1 at the RMS option and click the right button. 1 volt is equal to 19651.1 for the RMS option. The system is limited to 7 VRMS if we manage to choose 10 VRMS. Okay. Next is set the RMS 1 calibration for slot 2 to a value of 2. Next, set the peaks and RMS calibration for both slot 3 and slot 4 to the value of 1. Finally, make sure that the RMS2 unit is set to A as we will measure current. Upon completion of the customer setup calibration setting, press the save setting button to save the changes that have been made. Okay, for next point is picoscope. First major section is acquisition sample in one period. This setting stands for the number of samples. The higher the number of samples, the better sinusoidal graph is visualized. The maximum number of samples that can be set at 100K. The sampling interval that represent the accuracy of the measurement is the second section. For the third section to is the setting of the trigger that is intended to trigger impulse. We need to set the threshold level and the age to use the trigger setting to catch the impulse signal. Next, we need to make sure that the channel type is the same as the input port that we use to ensure that the output is measured. After all the setting, press ready and the system will start. And the lamp will change from green to red. Then there is a sound occurs and switch grounding will be function as safety. Okay, for the last point is the green lamp is indicating that the system is ready, and if it's turned to the red color means they are not allowed anybody entering the room. Okay, thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I am Mohammad Izzul bin Ramlan and I will explain for section 3 Okay, section 3, it contains its to table of comparison between the results of reference, key control and display picoscope. Okay, at these sections they have two table, which is a table for HV key and then table for picoscope 2000 series. Okay, this reading we get at the calibration of FC output that have been given so the reason that we do this comparison is to compare how which is better between HV kit and picoscope 2000 series, which is more accurate. Okay, for HV kit, this is the formula for percentage error, reference kilovolt RMS minus display kilovolt RMS divided with reference kilovolt RMS and multiplied by 100%. For picoscope, the formula is same, but we add square root. Okay, reference, this is the formula, reference kilovolt peak multiplied by square root 2 and minus display kilovolt square root 2 and then divided with reference kilovolt, also have square root 2 and then multiple by 100%. Okay, for the discussion after we finish this lab 3, we got that there is a difference between the reference value and the show value depending on the calibration based on the overall performance and measurement. In both of the output, the difference could be due to the sum causes, which is one of the variable is the scope sensitivity range. The reference value obtained from the key control is 11.809 kilovolt and the display value obtained from the picoscope is 10.87 kilovolt based on the table we obtained. For 10% output voltage, 7.95% is measured as the error between the two values. The difference in each of these values can also be caused by the coupling configuration. Accuracy is a measure of how accurate a measurement is to the right or accurate value of the quantity being calculated while performing a measurement, whereas accuracy is a measure of how nearer a number of measurements are to each other. Following is the calculation for the percentage error. Okay, this is the formula for the percentage error percent. Okay, reference minus with display and then divided with reference and multiple with 100%. Okay, for the conclusion, okay, at the end of this lab, we are capable of understanding how to calculate the percent error between the reference value and the display value with construction parallel AC high voltage measurement using the kit control 4.0 and picoscope 3000 series and picoscope 2000 series. Okay, besides, we are also able to compare and analyze the value obtained from the kit control as a reference value and the picoscope 3000 series as display value. Lastly, we also can understand and more familiarize to the process of the control 4.0 and the picoscope 3000 series PC. That's all, and that's all for me, and thank you.